Welcome to our tutorial. Today we are going to be looking at electric field intensity. So earlier in our previous video, we have explained, we start with Coulomb's law, and we say many things about force, and we know how if we have two charges. We explained that if we have two charges, so and the force that these two charges will experience, where it will be greater, is it when the distance is closer or when we have high distance separating the two charges. Today we are going to be looking at electric field intensity, and also we know when we compare the force of electric field and the force of gravitational field, we have already seen that the gravitational force, the electric force is greater than gravitational force. Now in this electric field intensity, we are familiar with, we already know what electric is, so we know what intensity is, that is and we know what field is. Now we now start with field. We say that a field is a region in space where the force is being experienced. That is, if you have a region or space, so any region where a force is being experienced by a charge or mass is what we call what? Is what we call field. And this, the example of this field can what? We can have gravitational force, gravitational field, we can have electric field. So that is what we mean by field. Now, if you now have electric field, electric field is just if you have two charges. Let's say we have yesterday I explained in our previous video, we talk about the test charge and the point charge. We say that we normally have test charge at the point charge, so which is always negative, and we use test charge to test. We normally use test charge if the test charge that we normally take closer to this point charge. Now if we now have two charges, we take a point charge, test charge, we take it close to point charge, so it will experience a force. The region or space in which this force is being experienced is what we call electric field. Now that's why we can just say electric field is a region in space where force is being experienced by what? By a charge that is placed in it. Now if we understand that, then we have what we call electric field line. So electric field line, they are the imaginary lines which a test positive charge will freely follow in an electric field. That is the electric field lines. We have electric field and the field itself. So now, this electric field line, it have a property in which we are going to be talking about the properties now. The properties of the electric field line. Let's look at now. The first properties of this field line is they do not cross each other. So they are always parallel to each other. Then they originate from positive charge and terminate at negative charge. That is, they always start from the positive charge and they terminate at the negative charge. I'm going to draw a diagram to explain this. They are perpendicular to the surface of the spherical charge. Then the field lines are closer to each other, where there is a strong field. So if this line, if they are closer to each other, so they will be closer to each other when we have a what? A strong field. And when they are far to each other, then we are going to have a weak field. So which we have explained that earlier. Then we say for an isolated charge, the field line terminates at infinity. So if you have in an isolated charge, positive charge, so the field line terminates at infinity. So the same thing for an isolated negative charge. So the field line originates at what? At infinity. So opposite of each other. Then the last one, the tangent to the field line represent electric field intensity. That is, if you have a field, electric field line, so any tangent to that line is what? Is the region where we can know the electric field intensity. Now, these properties of electric charges, so we say that for the positive charge, they always originate from the positive charge and they always terminate at the negative charge. Now we will show the representation of this. For isolated charge, that is, if you have isolated of two charges, let's say we have for positive charge, we can solve for the positive charge. They always terminate at the what? At the positive charge. They always originate, sorry, they always originate from the positive charge, and for the negative charge, they always terminate. Let's say we have the negative charge for an isolated charges. So we are going to have something like this. So this is the representation of the statement. And also, if we have for unlike charges, if you have, let's say, unlike charges, if you combine two charges together, let's say we have something like this: negative charge, positive charge. Oh. Now, since we said that they always originate from the positive charge, it means, and this is our positive charge, it means they will start, the direction will be like this, and also we are going to have something like this. And they will terminate at the what? At the negative charge. So the direction will be entering the negative. So that is, if you have two unlike charges, so the positive charge and the negative charge. So we see that the field will be moving in this way. So they will be moving from the positive toward the what? Toward the negative. So then we can also have for this is isolated charge, the unlike charge, and we can also have for the like charges. That is, if I just take, let's say, for like charges, let's say I just, let's say these two, they are what? They are negative charge. So we are going to, the direction of the electric line of force will be like this. And we said that the tangent to any line of this source is what? Is where there is what? There is electric field intensity. So if we just take a tangent to this line of force, then we are going to have what? We can detect our electric field intensity. So now we are now going to be looking at, now let's look at the field intensity. Now, what do we mean by the field intensity? That is, we want to be talking about the strength of electric field, the strength of the field. Now, we said that the strength of a field at a point is measured by its what? The strength of a field by a point is measured by its intensity. So, at that point, that is, if you want to measure the strength of a field at a point, so it will be measured by its intensity at that point. So, and the intensity represents the number of the field line. per what? Per cross-section area. So now I can just say that electric field intensity at any point is defined as the force per unit area. So the electric field intensity at any point is defined as the force per unit area. So the representation of this, the electric intensity at a point is defined as the point per unit should be charge. Per unit charge. That is per unit charge. So we can have something like this. The electric field will be equal to what? The force per unit charge, which is in vector quantity. Now, but from earlier from Coulomb's law, we already know what force is. You know that force is equal to K Q1 Q2 all over R squared. Now, the electric field will now be equal to what? K Q1 Q2 all over R squared divided by Q. So if I to have times here, I will just say multiply by 1 all over Q. So let's say Q2 or any. So this one can cancel this. Then the electric field can now be KQ1 all over R squared. So this is the electric field intensity. The electric field intensity at any point. Now, and the unit is what? From this, the unit for force is Newton, and this one is charge. Then I can just say Newton per coulomb. So, now, if you understand this, then we can now talk about the direction of electric field. As I said earlier, I said that anytime we are dealing with the force, the electric force, the electric field, the next thing we will be doing under this electric field potential. Under this electric field potential, so the most important thing is the direction. The most important thing is the direction. Now, you can silent like that. So the direction is outward. So the direction of the field strength E due to a positive charge is what? If we have a positive charge like this and we have electric field at this point P. So at this point P, then the direction is outward. That is, it will be moving in this direction. Because of what? This is a point charge. So, and this is a point charge, and we also have a test charge. The test charge we normally use a positive charge as a test charge. So if a positive charge and a positive charge, if they move closer to each other, they will what? They will repel. Then the direction will move outward. So then for the second one, the direction of field strength E due to a negative charge. And in this one, then our electric field will be equal to what? As we stated here, KQ all over R squared in Newton per coulomb. Now, for this one, the direction, if we have a positive charge like this, let's say we have our line. At here, we have a negative charge. So, the electric field intensity, they are separated by distance r. Let's say distance r. The electric field intensity will be what? Since we also have a negative charge, if we have a, our test charge is a positive charge. So if a positive charge is moving closer to this negative charge, then they will attract each other. Then the direction of our electric field at point P will be in this direction. Then it is moving to the what? To the negative. So our E will now be equal to what? Our E will be absolute value of minus KQ all over R squared. Because we are going to have negative answer. But if you take the absolute value means the absolute value of any number is positive. So then the electric field will now be equal to kq all over r square. Now, since you are, and also we can have the superposition in electric field, as we have stated earlier in the for the force. So if we have two charges, if we have many charges in any system, then we can calculate the net force in this system with respect to one of the charges to the neighboring charges. The same thing in the electric field. So the way we normally calculate in the normal for the force, then we can also do the same thing for the electric field. So we are going to be looking at the example under this electric field. Now let's try and do some example. So we just stop here for now. So in our next video, I'll be doing the example under this electric field, and we'll see how the direction, how we can take the direction, and if we have a superposition of electric field, how we can actually solve question under it. So if there is any question, you can type and send it to our inbox. Please like and subscribe to this channel. So meet you next time. Thank you.